Welcome to day 18 of Advent of Code. Today we will be running through RAM. So our algorithm is pushing whole bytes down on top of us, and our goal essentially is to escape from the RAM. So the memory space is a two-dimensional grid with coordinates that range from 0 to 70, both horizontally and vertically, and we need to so here's an example of how bytes are coming down on top of us. So this is a coordinate of x and y. And as the bytes fall, we need to figure out our way through the RAM. So we're starting at 0, 0, and we need to reach the bottom right corner, which is 70, 70. And after we simulate the bytes falling down, it kind of creates a maze that we have to run through. Because those areas which are marked with hashtag those are corrupted, and we cannot enter them because that would be dangerous for us. So we have to kind of walk around them and kind of find a path through the maze. So this means that we are going from top left corner to bottom right corner and kind of finding path through the maze. So initially, for our first run, we have to simulate the first kilobyte, 1024 bytes, falling down into the memory space and finding the minimum number of steps needed to reach the exit. Right, so let's try to do that. So for the sample input, I will take this one and just modify the dimensions accordingly. So they have 6 by 6 instead of 70 by 70. So private const int width will be 6. Height will be also 6. Now we need to read. So we're reading for the sample, we are reading just these 12 bytes. So private const byte count, it's going to be 12. So for byte count, we read in the byte, so 9 equals input read line async. Then we split the line, split by comma, and we kind of parse it. So parts, we do x and y, those are the coordinates of the byte, and we add it to our kind of map. So this is going to be private car map. So we initialize the map here, and we set the map to the corrupted byte. So after we process the bytes, we will find a path. So find path, and we length. So we find the length of the path, and it's going to be from 0, 0 to width -1, height -1. That's that. And now private int length, find path, point start, point end. So very basic breadth first search algorithm here. So Q, exactly what Copilot is suggesting, but I just need a Q of point, or actually, yeah, let's do a Q of point int, because that will allow us to track the number of steps as well. So it's going to be position steps, and we'll do enqueue start, and then while queue count is greater than 0, we'll get position steps. If the position is equal to end, we just return the steps we found by through, but otherwise we will also track the visited ones. Hash set point, so for each direction in directions without diagonals, we'll try to find the next one. So next, if it's within bounds, otherwise we skip it. And if it is within bounds, we check if it's not a wall that we are running into, and if yes, if not, then we basically those are the conditions. So if we already visited that point, then we continue, or we can push it all into one single if statement. So this one, or the map is a wall, or we already visited, then we continue. So those are the continue conditions, and then if not, then we add it to the next one and enqueue. Actually, we should enqueue also the start there. So enqueue enqueue in visited, and enqueue the next step with the number of steps we had to make to get there. And finally, we just return -1, which is never gonna happen. We will, well, in our case, it's not gonna happen. It could happen in some other case. So we add, why is it complaining here? Not sure, seems like a bug. So this should be hopefully enough. And we return the length of the walk. So let's see what happens when I run this. So it's gonna be problem 18. And we are running out of array somewhere. So let's bounds. Okay. What is the problem there? So the line is 6-3. Wait. 6. I see. All right. So what I made is a mistake that it's width and height of 7, but 6, but it's 7. Because the last point that we are going to is 6. So now it should be better. 22 is the right result. Yes. So we can get our puzzle input. And we need to modify our code to actually work with the right sizes. So 71, I think. Is that correct? Right corner is at 70. So 71. And we need to read in 1024 bytes. Right. Let's run with this. Yeah, not with the data. Okay. Yeah, I know. That's wrong. So we pick the input file, get it here, and run with the input file 322. Which is correct. Okay, so we have the first part solved. On to the next one. So we need to determine the first byte that will cut off our path to the exit. So after 1 falls, there is still path. After the next byte 6-1, there is no longer a path. So we look for the first byte that will prevent us from reaching the end of our path. Okay. 2 integers separated by comma is the output, so we need to find the first byte that is blocking our path. So there are 2 ways that we could approach this. One is brute forcing, just going through all the bytes and trying to find the first one that is problematic. But what I can do also to make it faster is to do length hash set points. So we could reconstruct the path from the end and just, instead of processing each new byte that's coming in, process only when there is a problem. So when the path actually needs to change. So this path. So we'll go by. We will reconstruct the path. So what I will do is go back through the maze. So for steps, and actually, I see. Right, we can do it more easily by doing previous one. So our previous new equals new dictionary point. So we'll check the previous ones. So while true, current equals position, and we will do a path equals new hash set point, and we will do current is not equal to start. We will add the current to the path. We'll get the previous one from the dictionary, and then just return steps and previous, so path, I mean. So when we're enqueuing into the queue, we have to also set the previous for the next point is the current position. Right, so that's what we have, and that should be enough to get us there. So now that we have this, we will be getting 2 things here. Also path. And we will not be stopping the processing. We'll stop when we find the first blocker on the path. So we'll find the path, and actually let's do a hash set here, hash set point last path. So this is going to be the last path we found. So last path, right? Actually, it can be, we can initialize it initially. So if last path count equals 0, or last path contains x and y. So if the last path that we had contained the current point, we will have to find the path, a new path that we will be using. So that's this, and now if the new byte that has fallen down is not on our previous path, we can just continue because the previous path is still valid for us. So that's this. And if the length is -1, we will return x plus comma plus y and kind of stop, because that's the place when we stop being able to find the next path. Right, so that seems to make sense to me at least. Hopefully it will be okay now, because we don't have a path. Okay, the part 2, and we will pick the input file right away. 22.9 is the problematic one, apparently. Oh, that's not the right answer. Okay. So what is the problem there? First byte will prevent from being reachable from starting position. There's 2 integers separated by comma with no other characters. That seems okay. So what is the problem? If it's equal to -1, not equal. Very basic problem there. So I think I would just output the first one. That wasn't great. So let's try again. Yeah, not this data. So input file 6021. That's better. Yeah, so 9 seconds to wait. So let's wait 9 seconds. And that is correct. Okay, so we have both parts solved. This one wasn't that hard. Actually, it was surprisingly easy after the previous day, which was quite complicated. So day 18 is done. And we'll see if ChatGPT can also solve it. This one seems like something that's doable for ChatGPT, so hopefully it will. And I will see you on day 19